All right, let's look at the next method of factoring, to factor by grouping. So factor by grouping can be broken down into three steps. Step one is to first group the terms. Step two is then to factor the greatest common factors out of each grouping, and then factor a common factor that's created out of the previous step. All right, so let's look at these three steps in the context of an example. So here we have an expression, and what we want to try to do is to try and factor this expression. So first thing we're going to do is we're going to group the terms. So group the terms just means we're going to put grouping symbols around two or more terms that appear to have some common factors between them. So for example, we've got xy plus 3y plus 2x plus 6. And if we put grouping symbols around xy plus 3y like that, all right, then we get the first part here. And then if we take 2x plus 6 and we put a grouping symbol around that, then we get this second part. Now, step two is then to factor out the greatest common factors between each group. So if we look at this first group, here, this is kind of, let me make sure this always shows. In the first group, we can see that the common factor between both terms x times y plus 3y is both terms have a y in it. So we can factor that y out. And then in the second grouping, we can see that 2x and 6 both have a factor of 2 that we can take out. All right. And what we have left is we've got x plus 3y, or I'm sorry, just x plus 3 here. And in the second grouping, we also have x plus 3. Okay, so that's step two. Step two is to factor out the greatest common factors out of each grouping. And then from these two, I'm sorry, now that we've got the greatest common factors outside of each grouping, we can now look at these separate groupings and see if they themselves now have common factors. And so we can see that this first expanded grouping has the factor x plus 3, and this second expanded grouping also has the factor x plus 3. So we could factor an x plus 3 out of this grouping and an x plus 3 out of this grouping, and we factor that x plus 3 out, then we get x plus 3 out in front. That was weird. All right. And then what we have left is y plus 2. So given this expression, x times y plus 3y plus 2x plus 6 can be written equivalently as x plus 3 times y plus 2. So being able to take an expression like this and rework it into this form, may allow us in rational equations, rational formulas, to be able to cancel some of these expressions out between a numerator and a denominator. So this is a very useful skill to develop here. Now, in this case, we just kind of took this expression as it was written, and we just put grouping symbols around the first and second and the third and fourth, like that. But sometimes it may not work out so nicely that way. You may have to maybe rearrange a few of the terms and then group them after you've rearranged them. and try it that way. Sometimes it'll give you um, no help whatsoever to do it that way. And sometimes you'll do it and it won't matter in the outcome. And that's kind of the example here, which is part of the reason why I give this note. If 2x and 3y were switched, if you switched these two around and you grouped them after you switched them, then the result is going to be the same. And, I say, well, try it just to kind of prove it to yourself that that's the case. All right, so I would go ahead and maybe try switching 2x and 3y and see if you get the same result. All right, so that's the definition of factoring by grouping with an example. Now, next, I've got these two think pair shares, and let's just kind of go over this really quick. So here with this first one, we've got x squared plus 3x minus 2x minus 6. And you can see that we can group this x squared plus 3x together. And then we have a negative. Let's see here. We have a minus 2x minus 6. Now, if we factor out this negative and put it outside this grouping, then this will be a positive 2x and a positive 6. All right, now we can look for common factors within each grouping. And we can see in this first grouping, each term has an x in it, so we can factor that x out. And that's the x that we get out. And what we have left is x plus 3. And in this second grouping, we can see that each term, this one and this one, has a factor of 2 in it. So we can factor a 2 out of each term. And so if we factor the 2 out of this term, all we have left is x. And if we factor a 2 out of 6, what we have left is a 3. Now between these two, we can see that we've got a greatest common factor of x plus 3. And if we factor that x plus 3 out and put it in front, then what we have left is x minus 2. So this expression here can actually be written as a product of those two expressions there. Okay, now in this next think pair share, we've got x squared plus xy plus 5x plus 5y. So we'll go ahead and group these like that. And in this first grouping, we can see that each term has an x in common. So we can factor out that x. And what you have left in the first term is just a single x. And in the second term here in this first grouping, what you have left is just a y. And in this second grouping, we can see that both terms have a constant 5 in common. So we can factor the 5 out from each term in that second grouping, put that outside. And what we have left, once the 5 has been factored out, is just x plus y. And between these two expanded groupings, each grouping has a common factor of x plus y. And so if we take x plus y out of both grouping, then we've got x plus y out in front, and what we have left is x plus 5. So this initial expression here can be written in an equivalent form as the product of x plus y times x plus 5. All right, so that's it for this factoring method. Let me know if you have any questions.